October 23, 1942, Second Battle of El Alamein, Egypt. British tank commander Lieutenant John Holman watched through his periscope as the new American Sherman tank to his right absorbed a direct hit from a German Panzer IV at 800 yards. The shell struck the Sherman's glacis plate and ricocheted harmlessly into the desert sand. The Sherman's turret traversed smoothly on its gyro stabilizer. The 75mm gun barked once, and the Panzer IV erupted in flames. Holman had spent 2 years fighting in undergunned cruiser tanks and mechanically unreliable Matildas. This American machine, with its seemingly modest 75mm gun, represented something the Germans had not anticipated. Industrial democracy applied to armoured warfare at a scale that would reshape the entire conflict. The Sherman's 75mm gun M3 appeared unimpressive on paper to Vermacht intelligence analysts, examining their first captured examples in Tunisia during early 1943. German tank designers had spent years pursuing incremental improvements in muzzle velocity and penetration values, constantly upgrading their Panzer III and IV designs with longer barrels and more complex ammunition. The American 75mm gun used a relatively short 40 caliber barrel that generated modest velocities compared to German tank guns entering service in 1942 and 1943. German ordnance officers noted these specifications with what appeared to be professional dismissal. The Americans had produced an adequate gun for 1942, perhaps suitable for engaging the Panzer III and early model Panzer IV, but clearly inadequate for the armoured battles unfolding on the Eastern Front, where German and Soviet designers competed in an escalating race toward heavier armour and more powerful guns. This assessment missed the fundamental reality that would decide the tank war. The Sherman's 75mm gun represented not an attempt at technical supremacy, but rather a deliberate choice to optimize industrial production and tactical flexibility. American ordnance designers had created a dual-purpose weapon equally effective against fortifications, infantry positions, and the medium tanks that comprised the vast majority of German armoured forces through 1943 and into 1944. The 75mm M3 gun could fire high-explosive shells with devastating effect against soft targets, while maintaining adequate armour-piercing capability against tanks the Sherman would actually encounter in combat. German tank designers, focused on defeating Soviet heavy armour, had created specialized weapons optimized for specific tactical situations. Americans had created a generalist weapon suitable for the combined arms warfare they intended to wage across multiple theatres against diverse opponents. The Sherman entered British service in North Africa in October 1942, carrying this 75mm gun that German intelligence had dismissed as adequate at best. Montgomery's 8th Army deployed approximately 300 Shermans during the Second Battle of El Alamein, and these tanks performed exactly as American designers intended. The 75mm gun penetrated the frontal armour of Panzer III and early model Panzer IV tanks at normal combat ranges exceeding 1,000 yards. More importantly, the high explosive capability exceeded anything British tanks had previously mounted, allowing Shermans to suppress anti-tank guns, destroy fortified positions, and support infantry advances with devastating effect. British tank crews, accustomed to vehicles armed with 2-pounder and 6-pounder guns, optimized for armour penetration but with minimal high explosive capability, found the Sherman's 75mm dual-purpose gun transformative for actual battlefield conditions. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The mathematical reality of tank production told a story. German planners refused to acknowledge until far too late. Between July 1942, when the first production model M4 tanks rolled off American assembly lines, and December 1943, 18 months later, American factories produced approximately 21,000 Sherman tanks of all variants. This staggering output represented more tanks than Germany produced across all types during the same period. The disparity revealed fundamental differences in industrial philosophy and manufacturing capability that no amount of technical superiority could overcome. German tank production remained bottlenecked by craft manufacturing methods, specialized components with limited interchangeability, and constant design modifications that disrupted production lines. American production applied mass manufacturing principles proven in the automotive industry, creating standardized components with full interchangeability and deliberate design stability that allowed production rates to climb steadily without interruption. German monthly Panzer IV production averaged 83 tanks during 1942, as manufacturers struggled to transition from the short 75mm gun to the longer high-velocity 75mm KWK-40. The longer gun required modified turrets, new recoil mechanisms, and revised internal ammunition stowage. These changes forced production pauses while tooling was modified and workers retrained. German tank factories operated more as specialized workshops than mass production facilities, employing skilled craftsmen who hand-fitted components and made individual adjustments to achieve proper function. This approach produced technically sophisticated vehicles when everything worked correctly, but it fundamentally limited production capacity and created maintenance nightmares in field conditions where precision adjustment tools and skilled technicians were unavailable. American Sherman production began at approximately 1,000 tanks monthly in mid-1942 and climbed rapidly to 2,000 monthly by late 1942 as additional factories came online and production methods were refined. The Fisher tank arsenal, part of the General Motors automotive empire, applied assembly line principles at unprecedented scale. The Chrysler Detroit tank arsenal, purpose-built for tank production, employed production techniques borrowed directly from automobile manufacturing. Lima Locomotive Works, Pressed Steel Car Company, Pacific Car and Foundry, Baldwin Locomotive Works, American Locomotive Company, Pullman Standard Car Manufacturing, and Federal Machine and Welder all contributed to Sherman production using standardized specifications that allowed components from any manufacturer to fit any vehicle without modification. A transmission built by Caterpillar Tractor installed perfectly in a hull constructed by Chrysler with an engine supplied by Continental. This interchangeability, routine in American automotive manufacturing, remained largely theoretical in German tank production, where each manufacturer introduced subtle variations. The production methods reflected deeper philosophical differences about the purpose of military equipment. German tank design pursued technical excellence under the assumption that superior engineering would compensate for numerical inferiority. Each modification to Panzer IV design specifications represented an attempt to match or exceed the capabilities of enemy armor through improved guns, thicker armor, or better optical equipment. These improvements came at the cost of production disruption and increased manufacturing complexity. The Panzer IV that entered production in 1942 with the long 75mm gun bore little resemblance to the vehicle produced in 1940, and by 1944 the design had evolved through multiple additional modifications. Each change required retooling, retraining, and disrupted supply chains for spare parts. Field units struggled to maintain vehicles as specifications, changed faster than technical manuals and spare parts inventories could be updated. American Sherman design deliberately prioritized production stability and field maintainability over incremental performance improvements. The basic M4 design established in early 1942 remained fundamentally unchanged through 1943 and into 1944, despite American engineers identifying numerous potential improvements. The decision to maintain design stability came from understanding that improvements interrupting production would cost more combat capability than any technical enhancement could provide. Better to field thousands of adequate tanks immediately than hundreds of superior tanks eventually. The American automotive industry had learned through decades of competitive commercial production that consistency and reliability mattered more than absolute performance specifications. A tank that worked predictably under all conditions had more military value than a theoretically superior vehicle that required constant expert maintenance. The 75mm gun remained standard equipment on Shermans throughout 1943, not because American designers believed it offered optimal performance, but because maintaining consistent production took priority over pursuing incremental improvements. American ordnance officers understood that the 75mm gun, while adequate against most German armour in 1943, would eventually face more heavily armoured opponents. Development work on a 76mm gun with improved armour-piercing capability began in August 1942, barely 2 months after initial Sherman production started. Prototypes underwent testing through late 1942 and early 1943, revealing various technical issues, including excessive muzzle blast and turret balance problems that required additional development time to resolve properly. The decision was made to continue producing Shermans with the proven 75mm gun rather than interrupt production to introduce the 76mm gun before it had been fully perfected. This production philosophy allowed Sherman output to climb steadily through 1943 without disruption. Monthly production exceeded 2,000 tanks consistently, peaking near 2,500 tanks monthly by mid-1943. The cumulative effect created overwhelming numerical superiority that made German technical advantages increasingly irrelevant. By December 1943, American forces and their allies had received over 21,000 Sherman tanks, while German forces had received approximately 6,000 Panzer IV tanks, 1,800 Panther tanks, and fewer than 1,350 Tiger tanks across all variants. The Sherman outnumbered all German tank production, combined by more than 2-to-1, and this disparity occurred despite the United States simultaneously conducting major operations in 2 separate theatres, while Germany focused most production on the single European theatre. The mathematical advantage multiplied when considering operational availability. Shermans required minimal specialized maintenance and could be repaired by mechanics with basic automotive training, using standard tools and readily available spare parts. German tanks demanded constant expert attention from specially trained technicians using precision tools, with spare parts availability declining steadily as Allied strategic bombing disrupted German industrial production. A Sherman battalion could maintain 80 to 90% operational readiness under normal field conditions. German panzer battalions struggled to keep 50% of their vehicles operational even when not engaged in combat. The Panther tank, technically superior to the Sherman in most specifications, averaged below 40% operational readiness through most of 1943, with some units reporting catastrophic rates as low as 20%. A technically inferior tank that functioned reliably had infinitely glacis, more military value than a superior tank that spent most of its time immobilized awaiting repairs. The Sherman's 75mm gun performance against actual battlefield opponents demonstrated the wisdom of American design philosophy. Through 1943 and into early 1944, the vast majority of German armoured vehicles the Sherman encountered were Panzer IV tanks, Stug III assault guns, and various light tank destroyers. Against these vehicles, the 75mm gun performed adequately at typical engagement ranges, routinely penetrating armour at 800 to 1,200 yards. The high explosive capability proved equally important for destroying anti-tank guns, fortifications, and infantry positions. Tank crews in North Africa, Sicily, and Italy reported high satisfaction with the 75mm gun's versatility and reliability. Loading procedures were simple and fast, allowing high rates of fire. The gyro-stabilized mount, an innovation unique to American tanks, allowed reasonably accurate fire, while moving, providing crucial tactical advantages during fluid combat. German tank crews who captured and operated Shermans during combat universally praised the 75mm gun's reliability and ease of use compared to German tank guns. The Sherman's semi-automatic breech design ejected spent shell casings automatically, allowing faster reload cycles than German tanks requiring manual extraction. The ammunition stowage arrangement provided ready access to shells, while German Panzer IV and Panther crews complained about awkward ammunition placement that slowed loading under combat conditions. The Sherman's turret basket rotated with the turret, keeping the loader positioned optimally regardless of turret orientation. German tanks lacked this feature, forcing loaders to reposition themselves as the turret traversed, further slowing firing rates. These seemingly minor details accumulated into significant practical advantages that battlefield reports consistently documented. The question of whether the Sherman's 75mm gun could destroy a Panther or Tiger became largely irrelevant in actual combat conditions. Shermans rarely engaged Panthers or Tigers in the one-on-one duels that post-war mythology emphasized. Tank combat occurred within combined arms operations, where artillery, air support, infantry anti-tank weapons, and tank destroyers all contributed to defeating enemy armor. Sherman crews learned to use mobility and numerical superiority to achieve favorable tactical positions, rather than relying solely on frontal gun duels. Multiple Shermans could overwhelm a single Panther through coordinated maneuver, with some tanks suppressing the target while others moved to flank positions where even the 75mm gun could penetrate side and rear armor. German Panthers and Tigers, magnificent in individual technical specifications, proved surprisingly vulnerable when surrounded by enemies attacking from multiple directions simultaneously. The industrial production reality made these tactical adaptations possible. American tank battalions could absorb losses and continue operations because replacement Shermans arrived steadily from American factories protected by thousands of miles of ocean from enemy interference. German panzer divisions lost irreplaceable vehicles every time a Panther or Tiger suffered mechanical failure or battle damage beyond field repair capability. Allied air superiority prevented Germany from moving tanks safely by rail during daylight hours, forcing nighttime movements that increased mechanical stress and reduced operational tempo. German tank commanders learned to carefully husband their limited assets, avoiding engagements where numerical superiority might overwhelm technical advantages. American tank commanders could afford to fight aggressively, knowing that losses would be replaced quickly, and that numerical superiority virtually guaranteed tactical success, even at unfavorable loss ratios. The 21,000 Shermans produced through December 1943 represented only the beginning of American tank production expansion. Factories continued operating at maximum capacity through 1944 and into 1945, eventually producing 49,324 Sherman tanks across all variants before production concluded. German total tank production of all types barely exceeded 25,000 vehicles for the entire war. The Sherman outnumbered German tank production by nearly 2-to-1, while also being supplied to British, Soviet, Free French, and other Allied forces through the Lend-Lease program. The mathematical advantage proved insurmountable, regardless of technical specifications or tactical excellence. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German tank designers eventually acknowledged the reality they had dismissed in 1942. American productive capacity could not be matched through technical superiority or tactical prowess. The Sherman's seemingly modest 75mm gun, adequate but unimpressive in German assessment, armed thousands of tanks that overwhelmed German forces through sheer numbers and operational reliability. Each attempt to improve German tank designs to counter perceived American deficiencies came at the cost of reduced production and increased mechanical complexity. The Panther represented German efforts to create a tank superior to the Sherman in every specification, yet Panthers contributed less to German combat power than Shermans contributed to Allied combat power. Technical excellence proved meaningless when production numbers differed by factors of 10 or more. Albert Speer, Minister of Armaments and War Production, understood the mathematical impossibility facing German tank production. His memoirs documented the growing realization that Germany could not produce enough tanks to replace combat losses regardless of individual vehicle quality. Strategic bombing disrupted component supply chains faster than production could adapt. Raw material shortages, limited output despite theoretical production capacity. Skilled labor shortages forced increasing reliance on slave labor that introduced deliberate sabotage and quality control problems. Every factor that constrained German production worked in favor of American production, safely located in factories far from combat zones, staffed by motivated workers earning good wages, supplied by raw materials from secure sources. and producing vehicles to stable specifications that allowed continuous production improvement without disruption. The Sherman's 75mm gun that German intelligence dismissed in 1943 armed the majority of American tanks that landed in Normandy in June 1944. American commanders specifically requested continued production of 75mm armed Shermans, even as 76mm armed variants became available, because the 75mm gun's dual-purpose capability better suited the infantry support role tanks actually performed most frequently. Tank battalion commanders understood through combat experience that high-explosive shells destroyed more enemy positions than armor-piercing shells destroyed enemy tanks. The decision to maintain production of 75mm armed Shermans reflected battlefield realities that specifications-focused German tank design philosophy never adequately addressed. The irony was complete and devastating. Germans had laughed at the Sherman's modest 75mm gun, dismissing it as adequate at best and inferior to German tank armament entering service in 1942 and 1943. Yet that adequate gun armed 21,000 tanks produced in merely 18 months, while German pursuit of technical superiority produced fewer than 10,000 medium and heavy tanks during the same period. The adequate gun worked reliably under all conditions, required minimal maintenance, and fired at rates German guns could not match. The adequate gun served in combined arms operations that overwhelmed German tactical excellence through material superiority. The adequate gun remained in production because Americans understood that consistency and reliability mattered more than absolute performance maximums. The Germans stopped laughing by early 1944 as Sherman tanks in overwhelming numbers supported operations in Italy and prepared for the Normandy invasion. German tank commanders faced the grim mathematics of attrition warfare, where every destroyed Sherman would be replaced by multiple new tanks, while every destroyed Panther or Tiger represented irreplaceable loss of combat power. The joke had become nightmare as American industrial capacity, dismissed by German planners as producing adequate but unimpressive equipment, proved capable of burying German technical excellence under avalanches of reliable, maintainable, and numerous tanks that simply worked when needed. The production statistics told a story that German war planners had failed to understand until circumstances made denial impossible. During 1943 alone, American factories produced approximately 21,000 Sherman tanks, while German industry struggled to manufacture roughly 6,000 Panzer IVs, 1,850 Panthers, and 650 Tigers. The disparity extended beyond simple numbers into fundamental questions about industrial philosophy and resource allocation. Each Panther tank required approximately 150,000 man-hours to produce using specialized labor and precision manufacturing techniques. Each Sherman required roughly 10,000 man-hours using mass production methods and semi-skilled labor trained in automotive assembly techniques. Germany was spending 15 times the labor to produce one technically superior tank, while America produced 15 adequate tanks with the same labor investment. The mathematics were brutal and unforgiving. German factories operated under constraints American manufacturers never faced. Allied strategic bombing targeted key production bottlenecks with increasing accuracy through 1943 and 1944. The Maybach engine plant at Friedrichshafen, critical for Panther and Tiger production, suffered devastating damage during an RAF raid on the night of April 27 to 28, 1944. The attack involved 322 aircraft and destroyed both the engine factory and the adjacent ZF gearbox facility. Panther and Tiger production halted completely for 6 months. When manufacturing finally resumed in November 1944, quality control had degraded catastrophically. Slave labor, increasingly employed as German workers were conscripted for military service, introduced deliberate sabotage into production. Cigarette filters jammed oil passages, gaskets installed incorrectly, critical components assembled without proper clearances. These problems never affected Sherman production in American factories, staffed by motivated workers earning competitive wages under decent working conditions. The Chrysler Detroit tank arsenal represented everything German tank production was not: Purpose-built for tank manufacturing in 1940, the facility occupied over 100 acres and employed nearly 40,000 workers at peak production. Assembly lines stretched for hundreds of yards, with specialized workstations performing specific tasks in carefully choreographed sequence. Workers received training in specific assembly procedures, but required no general mechanical expertise. The production process assumed that ordinary people with basic training could build complex machines if the manufacturing system was properly designed. This democratic approach to industrial production reflected fundamental American social philosophy and stood in stark contrast to German manufacturing that relied on craftsmen with years of specialized training performing complicated fitting and adjustment procedures. Detroit tank arsenal production peaked at 750 Sherman tanks monthly during 1943, representing more tanks in 1 month than some German factories produced in entire years. The facility achieved this output while simultaneously training new workers, incorporating design improvements, and maintaining quality standards that exceeded military specifications. Inspectors stationed along assembly lines checked critical measurements and functions at multiple points, rejecting any component that failed to meet tolerances. Rejected components were immediately replaced with parts from the vast inventory of standardized components that ensured any piece would fit any vehicle without modification. This inventory system, routine in American automotive manufacturing, remained largely theoretical in German tank production, where individual craftsmen created parts fitted to specific vehicles. The Sherman's 75mm gun benefited from this production philosophy in ways German ordnance specialists never fully grasped. The M3 75mm gun was manufactured by multiple suppliers, all building to identical specifications. The gun mount, recoil mechanism, breech assembly, and fire control systems were all produced by separate manufacturers, whose components assembled together perfectly without hand fitting. If a gun mount failed in combat, field mechanics could install a replacement from any manufacturer without adjustment. German tank guns required precision fitting by skilled technicians using specialized tools, making field replacement of major components nearly impossible. Sherman crews could swap out a damaged gun mount in hours using basic tools and standard procedures. German Panther crews required factory-level facilities to replace major gun components. The ammunition production for the 75mm gun demonstrated similar industrial advantages. American factories produced 75mm shells by the millions, using automated production lines that required minimal skilled labor. Shell casings were drawn from brass stock using hydraulic presses. Projectiles were machined in automated lathes. Propellant charges were measured and loaded using mechanical systems requiring only basic operator attention. Final assembly brought components together with quality control checks at every stage. The resulting ammunition functioned reliably under all conditions, from Arctic cold to tropical heat, with failure rates so low that American tankers took reliability completely for granted. German tank ammunition production employed more labor-intensive methods with greater variation in quality. Field reports documented German ammunition failures occurring at rates that would have been considered scandalous in American service. The 75mm gun's optical systems reflected the same production philosophy. The M38A two-telescopic gun sight provided adequate magnification and clarity for typical engagement ranges using relatively simple optical design that could be mass-produced with consistent quality. American optical companies like Bausch and Lomb applied precision manufacturing techniques developed for commercial products, creating military optics that were good enough for battlefield conditions while remaining simple enough for mass production. German tank optics pursued maximum theoretical performance, using complex lens designs that required skilled optical technicians to produce and adjust. The resulting optics were often superior in laboratory conditions, but proved fragile in field use and difficult to repair or replace. Sherman gunners might have slightly less perfect optics than their German counterparts, but they always had working optics because replacements were readily available and easily installed. The gyro-stabilized gun mount on the Sherman represented American innovation applied to practical battlefield problems. The system used a gyroscope to detect tank motion and automatically compensated for vehicle movement, allowing reasonably accurate fire while the tank was moving. The stabilization was imperfect by laboratory standards, working on only the vertical axis and providing limited correction. But it gave Sherman crews significant tactical advantages in fluid combat. German tanks lacked any stabilization, requiring them to stop before firing accurately. This seemingly minor difference accumulated into major tactical advantages across thousands of engagements. Shermans could advance under fire while suppressing enemy positions. German tanks had to choose between movement and accurate fire. The stabilization system added complexity and cost to Sherman production, but American designers considered the tactical advantage worth the investment because it made the complete weapon system more effective, even if individual components were less technically sophisticated. By mid-1943, German intelligence had accumulated enough battlefield data to understand the magnitude of their miscalculation. Captured American planning documents revealed production targets exceeding anything German industry could contemplate. Roosevelt had announced goals of 120,000 tanks for the Allied war effort. German analysts initially dismissed these figures as propaganda, but accumulating evidence confirmed American productive capacity matched or exceeded announced targets. The implications were devastating. Germany was fighting an opponent whose industrial capacity exceeded German capacity by factors of 10 or more in some categories. No amount of technical excellence or tactical skill could overcome that disparity. The war would be decided by industrial output, and Germany had already lost that contest before the first Sherman rolled off an American assembly line. Wehrmacht officers, reviewing intelligence reports from North Africa and Italy, noted disturbing patterns in Sherman deployment. American tank battalions maintained operational readiness rates that German units could never match. Shermans lost to combat damage or mechanical failure were replaced within days by new tanks shipped from American factories. German panzer divisions operated with chronic shortages, often fielding barely half their authorized tank strength due to irreplaceable losses and mechanical failures. American tank companies rotated vehicles through maintenance cycles that kept them operational without requiring extensive overhaul. German tank companies struggled to maintain even minimal operational capability, as aging vehicles required increasingly frequent repairs with increasingly scarce spare parts. The simplicity of the 75mm gun system contributed to this operational advantage. Sherman crews could perform basic maintenance on the gun system using instructions in technical manuals written for ordinary soldiers. Cleaning the bore, checking recoil fluid levels, adjusting elevation and traverse mechanisms, replacing worn components, all these tasks required only basic mechanical aptitude and standard tools. German tank guns demanded specialized knowledge and equipment for many maintenance procedures. The Panther's 75mm KOK 42 gun, technically superior to the Sherman's gun in almost every specification, required expert attention to maintain proper function. The recoil system used complex hydraulic components that failed frequently and required precision adjustment to function correctly. The elevation mechanism proved fragile under sustained use. The gun mount itself sat on bearings that wore rapidly and required specialized tools to service. A Panther might have a superior gun on paper, but that superiority became meaningless when the gun was non-functional and no technicians or parts were available for repairs. German tank commanders learned through bitter experience that American numerical superiority and operational reliability mattered more than technical specifications. A report from the 10th SS Panzer Division in January 1945 noted the irony that captured Shermans were preferred for reconnaissance missions, specifically because they could be counted on to function when needed. The division had captured 12 M4A3 Shermans at Herlisheim during Operation Nordwind and formed them into a reconnaissance company that operated until the war's end. The report praised the Shermans' mechanical reliability, noting that all 12 vehicles remained operational after months of combat use, while German tanks suffered constant mechanical failures. The division's Panthers, technically superior in every specification, could not be relied upon for sustained operations because mechanical problems disabled them unpredictably. The mathematics of attrition warfare became unavoidable by 1944. Allied forces could trade tanks at unfavorable loss ratios and still maintain numerical superiority because American production replaced losses faster than combat could inflict them. German forces had to carefully husband limited tank resources because losses were essentially irreplaceable. A Panther battalion losing 3 tanks in combat had permanently lost 15% of its combat power. A Sherman battalion losing 10 tanks would be back to full strength within a week, as replacement tanks arrived from rear area depots. This fundamental disparity in replacement capacity meant that aggressive German tactics became increasingly costly as the war progressed. Each offensive operation depleted irreplaceable German tank strength while inflicting replaceable losses on Allied forces. German panzer commanders began receiving explicit orders in late 1943 to avoid unnecessary engagement and preserve tank strength for critical operations. Panthers were too valuable and too scarce to risk in routine combat. The finest tank in the German inventory became so precious that it could not be used freely, negating whatever tactical advantages its superior specifications provided. Meanwhile, Sherman commanders operated under no such restrictions. Tanks were tools to be used aggressively because losses would be replaced. This psychological difference proved as important as material differences. Aggressive action created tactical opportunities, while cautious conservation surrendered initiative to opponents who exploited hesitation ruthlessly. The German tank production crisis deepened through 1944, despite desperate efforts to increase output. Monthly Panther production peaked at 379 tanks in July 1944, representing the maximum capacity German industry could achieve under wartime conditions. This maximum German output was exceeded by multiple individual American factories producing Shermans. The Fischer tank arsenal alone produced more Shermans monthly than Germany produced Panthers. Chrysler's Detroit tank arsenal produced comparable numbers. Grand Blanc, another General Motors facility purpose-built for Sherman production, added additional capacity. The mathematical disparity was so overwhelming that no conceivable German production increase could have closed the gap. Even if German factories had somehow doubled Panther output, American production still would have outnumbered German production by substantial margins. The quality gap further favored American production as German manufacturing deteriorated under sustained Allied bombing and resource shortages. Late-war Panthers exhibited declining build quality as experienced workers were conscripted and replaced with slave labor. Components no longer fit precisely. Welds showed poor workmanship. Critical tolerances were not maintained. These quality problems resulted in tanks that failed mechanically even without combat damage. Some late production Panthers broke down before reaching the front, mechanical failures occurring during the rail movement from factories to combat units. The vehicles that did reach combat units required constant maintenance to remain operational, maintenance that overtaxed field repair capacity and consumed resources needed for other equipment. Sherman production. Quality remained consistent throughout the war. American factories maintained exacting standards that actually improved as production experience accumulated. Late-war Shermans were better built than early production models, with design improvements incorporated without disrupting production schedules. The wet ammunition stowage system, introduced in 1944, dramatically reduced fire risk after penetration. The modification was integrated into production seamlessly, with new vehicles rolling off assembly lines carrying the improved design, while earlier vehicles could be retrofitted during routine maintenance. This ability to evolve the design incrementally while maintaining production continuity demonstrated mature industrial capability that German factories never developed. The introduction of the 76mm gun on some Sherman variants in 1944 demonstrated American production flexibility. The new gun offered significantly improved armor-piercing capability against heavy German armor, while maintaining the reliability and ease of use that characterized the 75mm gun. Production began in January 1944, with 76mm armed Shermans arriving in Europe by April. The transition occurred without disrupting 75mm production because American industry could produce both variants simultaneously. Tank battalions could select the mix of 75mm and 76mm armed tanks that best suited their tactical situation. Some commanders preferred 75mm armed tanks for their superior high-explosive capability against infantry and fortifications. Others requested more 76mm armed tanks for better anti-tank performance. American production accommodated both preferences without difficulty. German forces never achieved this production flexibility. Panther production locked Germany into a single design that could not be modified without disrupting output. When problems were identified, German engineers had to choose between continuing production of flawed vehicles or halting production to implement fixes. Either choice was unacceptable, yet those were the only options available. American factories routinely made design improvements without production interruption because the manufacturing system was designed to accommodate change. This flexibility reflected decades of commercial automotive production experience, where annual model changes were routine and expected. The final accounting of the Sherman's 75mm gun legacy came in the comparative production statistics that told an unambiguous story. American factories produced approximately 38,000 Shermans, armed with the 75mm gun between 1942 and 1945. This single gun variant outnumbered total German production of all tank types combined. The gun German intelligence dismissed as adequate armed more tanks than Germany, Britain, and the Soviet Union produced collectively in some categories. The modest, unimpressive, adequate 75mm gun proved more militarily effective than any German tank gun because it armed tanks that actually existed in overwhelming numbers, that actually worked when needed, that could actually be maintained by ordinary soldiers, and that could actually be replaced when lost. The strategic implications extended beyond tank warfare into fundamental questions about industrial mobilization and military effectiveness. Germany entered World War II assuming that technical superiority and tactical excellence would compensate for material disadvantages. This assumption proved catastrophically wrong. Technical superiority became irrelevant when the technically superior equipment could not be produced in sufficient quantities to affect battlefield outcomes. Tactical excellence became meaningless when tactical victories consumed irreplaceable resources, fighting enemies who replaced losses faster than combat could inflict them. Germany fought the war its generals wanted to fight, a war of maneuver and decisive battle where quality defeated quantity. America fought the war its industrial capacity allowed, a war of material attrition where overwhelming production capacity ground down opponents regardless of individual engagement outcomes. The Sherman's 75mm gun represented American recognition that adequate equipment produced in overwhelming quantities defeated superior equipment produced in inadequate quantities. This insight came from decades of commercial competition in the automotive industry, where successful manufacturers understood that reliability and availability mattered more to customers than absolute performance maximums. A car that worked consistently and could be serviced anywhere was more valuable than a faster car that broke down frequently and required specialized service. This customer-focused philosophy transferred directly to military equipment design. A tank that worked consistently and could be maintained anywhere was more valuable than a more powerful tank that broke down frequently and required specialized maintenance. German tank design philosophy pursued engineering excellence under the assumption that soldiers would adapt to equipment requirements. American tank design philosophy adapted equipment to soldier capabilities, assuming that ordinary people with basic training would operate and maintain the equipment. The difference proved decisive. German tanks demanded expert operators and maintenance personnel who became increasingly scarce as the war progressed. American tanks functioned adequately when operated by minimally trained crews and maintained by mechanics with basic automotive knowledge. This difference multiplied across thousands of tanks and millions of service hours. German panzer divisions became less effective as experienced personnel were killed or wounded and could not be adequately replaced. American tank battalions maintained consistent effectiveness because new personnel could rapidly achieve minimal competence with equipment designed for ease of use. The laughter stopped completely by late 1944 as German forces retreated on all fronts under pressure from enemies equipped with seemingly inexhaustible supplies of Sherman tanks. German commanders, who had dismissed American equipment as adequate but unimpressive, now faced the reality that adequacy in overwhelming quantities defeated excellence in inadequate quantities. The Sherman's 75mm gun, unimpressive in specifications, had proven devastating in application, not because it outperformed German guns in individual engagements, but because it armed thousands of tanks that German industry could never match and German forces could never defeat through tactical excellence alone. The final irony emerged in post-war analysis when historians and veterans assessed tank effectiveness. The Panther received praise as perhaps the finest tank of World War II, combining firepower, protection, and mobility in an optimized package. The Tiger was remembered as fearsome and nearly invulnerable in frontal engagement. The Sherman was often dismissed as adequate at best, a tank that won through numbers rather than excellence. This assessment missed the fundamental point. The Sherman was deliberately designed to be adequate because American engineers understood that adequate equipment produced in overwhelming quantities and maintained reliably would defeat excellent equipment produced in inadequate quantities and maintained poorly. The Sherman won because it was adequate, not despite being adequate. Adequacy at scale was the strategy, not a compromise. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.